Hi students, so welcome you all. Okay, so today let us take the problems on continuity chapter. Okay, so I'm going to solve some of the important problems on continuity chapter, and I think already you know those particular problems, but no problem. So once again, we shall solve them and revise those problems. Okay. So here the first one is, see the first problem, that is find find k if f defined f defined by f of x equal to x square sine of 1 by x if x is not equal to 0, and k if x is equal to 0 is continuous at is continuous at is continuous at x equal to 0. Okay, so here we have to find the value of k, where the problem is given as it is continuous at x equal to 0. If x is not equal to 0, x square sine of 1 by x. If x equal to 0, that is k. Okay, if the function is continuous at x equal to 0, you are going to take LHL is equal to RHL is equal to f of a. That is nothing but f of a is equal to limit extending to a f of x. Okay. So LHL equal to RHL is nothing but limit extending to a f of x, and that is equal to f of a. So here you can just see f of 0 is what? F of 0 is k. You just see at x equal to 0, you have k. So f of 0 will be equal to k. At x equal to 0, you have k. So that's why f of 0 will be equal to k. Clear? And another term is limit extending to 0 f of x. So that is going to be equal to limit extending to 0, that is x square into sine of 1 by x square into sine of 1 by x. So here this term is going to be limit extending to 0 x square and limit extending to 0 sine of 1 by x. I can write like this, no problem. So now from this, see, if x is going to be 0, 0 square is again it is becoming 0. 0 into anything is what? 0 itself, right? So 0 into anything is 0. So here use this equation 1. So therefore f of a is nothing but f of 0 is equal to limit extending to a f of x. So here you have f of 0 as k. Here you have f of 0 as k, So you take that term, that is f of 0 is equal to k. So write f of 0 equal to k, and this term, see here you got 0. So k equal to 0 will be the answer. Clear? So if you have any confusions, see I will explain once again. Find the k if f defined by f of x equal to x square sine 1 by x if x is not equal to 0, and k if x equal to 0. So here we know that left hand limit must be equal to right hand limit must be equal to f of a for continuous function. So here you can just see this is nothing but limit extending to a f of x. Left hand limit is equal to right hand limit means limit extending to a f of x is equal to f of a. Okay. So for that reason, here we can just see our equation 1. So from equation 1, you write limit extending to 0 f of x, that is limit extending to 0 x square sine of 1 by x. So here you have two functions, apply limit for both the functions. So once you apply the limit for both the functions, it will be limit extending to 0 x square, limit extending to 0 sine of 1 by x. So if I put x value as 0, it will be 0 multiplied with limit extending to 0 sine of 1 by x. So 0 into anything is 0. So use our equation 1, that is f of a equal to 0, and limit extending, sorry, f of a is k. At x equal to 0 you have k, and this term here it is 0. So therefore k equal to 0 is your answer. Okay. So I think this problem is clear. If you have any confusions, you can comment in the comment box. No problem. If you don't have any doubts, I will go for the next problem, and we can see the next problem. Okay. So see the second one, that is find the value of k. Find the value of k if f of x is equal to kx plus 1 cos x. So here if x is lesser than or equal to pi, and here this is if x is greater than pi, is continuous at x equal to pi, is continuous at x equal to pi. Okay. So see here again we have to use our continuous function definition. What is continuous function definition? That is limit extending to a f of x is equal to f of a. Okay. So here you can first find f of pi, that is nothing but your f of a. A value is pi. So f of pi is how much? See at x equal to pi, your value will be kx plus 1. So that is k pi plus 1. On the same way, you find the second term, that is limit extending to a f of x is going to be equal to limit extending to a f of x is how much? Cos x. Okay. So a value is pi. That is limit extending to pi. You have here cos x equal to f of a term is k plus 1. That is k pi plus 1. So now we have extending to pi, that will be cos pi equal to k pi plus 1. So you know that cos pi is equal to minus 1. So therefore minus 1 equal to k pi plus 1. Take plus 1 on this side, it will be minus 1. So minus 1 will be minus 2 k pi. So k will be equal to minus 2 by pi. So this is the answer, that is minus 2 by pi. So someone have any doubts, you can put in the comment box, no problem, so that I can reply for their doubts. Okay. So this is just 30 minutes class. So that's why I have taken some important problems of your continuity function. So daily from 9 to 10, I will be having 1 hour class. So don't miss that. Okay. In that we are discussing very important problem. So please don't miss that. Clear? Okay. So now we shall go for the next problem. Is the third one. Find the value of k if f of x is equal to kx plus 1 if x is lesser than or equal to 5, and another function is 3x minus 5 if x is greater than 5, is continuous at x equal to 5, is continuous at x equal to 5. So here we can just see again the same definition. If it is continuous, limit extending to a, f of x is going to be equal to f of a. So for f of a, we have f of 5. So that is equal to k into 5 plus 1. At equal to 5, you have kx plus 1. That's why at f of 5, we have 5k plus 1. So this is 5k plus 1. And for limit extending to 5, f of x will be limit extending to 5, f of x is 3x minus 5. Okay. So for that, you just see x value is 5. 3 into 5 minus 5. 15 minus 5 will be equal to 10. So this term we got it as 10, and f of a we got it as 5k plus 1. So if I simplify this, it will be 5k equal to 9, k equal to 9 by 5. This is your answer for value of k, that is 9 by 5. So I think these problems can help you for your board exam. So that's why be careful regarding these problems. And here you got the k value as 9 by 5. Okay. So now we can see the next problem is find the value find the values of k if f of x is equal to k times of cos x divided by pi minus 2x if x is not equal to pi by 2, and another term is 3 if x is equal to pi by 2, is continuous at x equal to pi by 2, is continuous at x equal to pi by 2. Okay. So we can just see the solution, that is limit extending to a, f of x is equal to f of a. So you remember this definition. So from this definition, we can simplify our required answer. Okay. So here limit extending to pi by 2, k into cos x divided by pi minus 2x. You have this term. Clear? So to simplify this term, in the denominator what I will do, I will take 2 as common. So if I take 2 common, here you have k. So write k by 2 outside, limit extending to pi by 2. What is remaining term? Here cos x divided by what? If I take 2 term common, it will be pi by 2 minus x. See here, from this I am taking 2 as common. From this term I am taking 2 as common. So if I take 2 as common, it will be pi by 2 minus x. In the numerator you have cos x, so no problem. So k by 2 limit extending to pi by 2 cos x divided by pi by 2 minus x. So that is k by 2 limit extending to pi by 2. How can you write cos x? You can write cos x as sine of pi by 2 minus x. Very good. So pi by 2 minus x. So just you remember the formula that x limit extending to 0 sin theta by theta term is 1. So here you are going to have k by 2 multiplied with 1. So that is nothing but k by 2. So limit extending to pi by 2, k cos x divided by pi minus 2x is going to be equal to k by 2. So from that, here you get this term as k by 2, and f of a, that is nothing but f of pi by 2 at x equal to pi by 2, your value is 3. So k by 2 equal to 3 and k will be equal to 6. This is the answer. Okay. So from this, I think you can understand how to simplify the problems for finding the values of k. So for that's why I have solved nearly 4 problems. Please be careful regarding these 4 problems. So many times in the annual exam, they have asked these 4 problems. And there are some more problems which are very, very important. I will see how many of them will get simplified. So if you have any doubts regarding these 4 problems, you can just put the question so that I can reply for your question and I can clarify your doubts. So just see if you have any confusions, you can ask the question. Otherwise, I will go for the next problem. Is find find the values of A and B. Find the values of A and B such that the function defined by f of x is equal to 5 if x is lesser than or equal to 2, ax plus b if x is greater than 2 and lesser than 10, and 21 if x is greater than or equal to 10. So this is the given function. So good evening to everyone. You just watch this video where I am solving the important problems of continuity for your board exam. Okay. So is continuous function. So this is given is continuous function. Clear? So here if this is continuous function, see here you have 2 points. One is 2, another one is 10. So that what happens, you have to verify the continuity in both the points at x equal to 2 and at x equal to 10. So be very cautious regarding this particular problem, because here you have to check at x equal to 2 and at x equal to 10 both the values. So here you have to verify limit extending to a, f of x is equal to f of a. Here also you have to verify limit extending to a, f of x equal to f of a. So in both the cases you have to verify. So here at x equal to 2, limit at x equal to 2, f of x is, see here, at x equal to 2, f of x is 5. And f of a, so you have limit extending to a, f of x, okay, sorry. So for limit extending to 2, your function is ax plus b. Your function is ax plus b. And for f of a at x equal to 2, it is 5. So a times of 2, because x value is 2, that will be 2a plus b. That will be 2 times of a plus b equal to 5. 2 times of a plus b equal to 5. This is equation 1. On the same way here, f of a at x equal to 10, you got 21. So then limit extending to 10, you have the equation ax plus b. So x value is 10, 10a plus b equal to 21. So this is your equation 2. Okay. So from this you got two equations, that is equation 1 and equation 2. Now we have to simplify equation 1 and equation 2. So that is solving equation 1 and 2. Solving equation 1 and 2. That is 2a plus b equal to 5. 10a plus b equal to 21. So here if I subtract this, this will be minus 8a. So this will get cancelled. If I subtract here, it will be minus 16. That implies a equal to 2. That implies a equal to 2. Okay. So if a equal to 2, put in any equation. So that is 2 times of 2 plus b equal to 5. So b will be equal to 1. Therefore, a is 2, b is 1. This is the value of a and b. Clear? So like this, you have to simplify your problems so that you can get the results of the values of a and b. I think we have solved 5 important problems. So from that 5 important problems, you can understand how to simplify the value of k, how to simplify the value of a and b, and so on. We shall solve one more problem. We shall solve one more problem, that is define continuity of a function at a point. Next, find all the points of discontinuity. Find all points of discontinuity of f defined by f of x equal to mod x minus mod of x plus 1. Okay. So see the answer. First read the question very carefully. Define continuity they are telling. So first we have to define continuity function. That is a real function f of x is said to be continuous, is said to be continuous, is said to be continuous if and only if, or you can say is continuous if limit extending to a f of x is equal to f of a at x equal to a, at x equal to a. So this is the definition of continuity function. And now we have to find the discontinuity of f of x is equal to mod x minus of mod of x plus 1. So here we know that, here we know that mod x and mod of x plus 1 both are continuous function, both are continuous function. Because why? You just see, because y means modulus function is always continuous. Please remember, mod function, mod function is continuous, mod function is continuous. That's why here mod x and mod of x plus 1 both are continuous. Therefore mod x minus mod of x plus 1 is also continuous, is also continuous. Therefore no points of discontinuity, therefore no points of discontinuity, therefore no points of discontinuity. Clear? This is the solution for the required problem. Okay, so these are the some important problems for your board exam of continuity topic, and this will be asked for 4 marks in the part E. The part E, please be careful, where part E will be for 10-mark portion. There one question from LPP, one question from properties of definite integral, one question from your matrices topic, and one question from continuity. So these 4 questions are going to be there for the part E. So that's why be careful. In there they can ask one of this problem, and I think continuity is very easy comparing to other matrices problems, and the LPP is very easy comparing to your definite integral properties. So be careful. In the part E you have to solve same question. For example, if you are solving 49, in the 49 you have to solve A and B. If you are solving 50th question, there you have to solve A and B. You can't solve A from 49, B from 50. Okay, so that never happens. If you do like that, they will not provide any marks. They will provide either 6 or 4. They will not provide complete 10 marks. So that's why be careful, and best of the luck. Do well.